Hello, in this short video I would like to introduce you to the concept of model cars, a new way with which you can efficiently initialize model data for KServe. But before we start, let's have a quick look how storage or model initialization usually looks like. So what you see here is a schema how the storage initializer is working. So usually you have your model data in some external storage like S3 or maybe on Google Cloud. Then during the initialization of the pod that belongs to your inference service, the init container here copies over the model data which comes from the external storage to a volume which is an empty volume, so it's running on the node itself, copies it over, then the init container stops, and finally the user container, which is the KServe container containing your serving runtime, starts and will pick up the model data from this empty directory. So this is the approach. This works nicely, but has some severe drawbacks when it comes to performance, especially when your model data is large. Because of course the pickup of the model data from an external storage and copying over in an empty directory takes some time, and this can take up to several minutes for large data which are beyond 1 GB, which is not untypical for large language models, for example. So to overcome this, there has been some proposals like with Fluent, but actually in this demo I want to show you an alternative approach which leverages a certain feature of Kubernetes, which is, let me just switch here over, so which is about a feature which is called share process namespace. So you can, this is a field of the pod spec, and you can set that this to true. In this case, all your user containers share the same process namespace and can not only access each other processes, but also can access each other's root file system, which is important for this feature. So in this case, again, you have your model data, but you don't put it into an external storage, but you package it into an OCI image with Docker, for example, Docker build, then push it to your OCI registry. And from there, it's accessible for your pod from your inference service. The inference service in this case does not have any init containers, but actually have two application containers, which are so-called sidecars. And one sidecar, which I called modelcar, actually contains your model data, and refers to the image that you have created. When this modelcar image starts up, it also has access to an empty dir volume like here, but and in addition it creates a symbolic link to its own model data, and it's accessed via the proc file system here. Then if this happens, your KServe container can access your model data directly from this empty dir volume by following this link, which points directly into the container of your model car. And for that you don't have any copying action, so you don't have to copy over any model data, but directly access the data which appears within the image. Of course, the benefit is if your image is already into your Kubernetes cluster, has been downloaded once, of course for the first time you still need to download the full image, which is might be large and which takes some time, though there is no benefit really over the storage initializer. But if you call it a second time, or if you scale up or down to 0 and back up to 1 again, then your image is already present, and then the startup goes into 1 or 2 seconds, so which is a big advantage over the way like storage initializer, which would have to copy the data again and again. Okay, so this is about the theory. Now let's move over to some little demo here. So first of all, let's have a look how this model car container image looks like. I have here a sample. Let's look into that. So the Docker file is very simplistic. So you have only, you run it from a busybox, for example, a very small container base image. And then you just add your model directly into the root models directory. And if you look into the model, so what I have here is I have here in this case, a very small small model, sorry, about from the sklearn the demo. Okay, let's assume you have created this image. Then you can apply it, like here. So let's assume I have pushed it here to this container image, to a registry. And then the important part here is that the pull request that I'm proposing introduces a new schema for the storage URI, which is called OCI. So this is triggers then the way how you can use this model car feature. And that's all. So actually you use that, you apply it to your cluster, then of course the inference service then in turn will create a Knative service, and the Knative service and call cube control get pod minus v. So actually it already has been started here, and you see now the difference is, so the pod is actually the pod which has been created on behalf of the Knative service, sorry. And what you see here now is that instead of having two containers into your pod, so one is the your usual runtime container, and the other one is the queue proxy, which comes from Knative service. You have an additional one, the third one. This is the model car container. And now let's have a look into the container itself. So actually I'll jump here. Car exec minus it here like this one. Let's jump into the KServe container. So this is the one which holds the runtime, and run bash here. So this is the runtime container. You see here, you have running here your sklearn server. So this is coming from this demo. And now let's look into the model directory. And if you look here, if you look here, sorry, I have to go to the mount, mount directory. If you look here, you see the model directory again. Let's look into the models, and you see now that it's pointing to the proc file system of another container. And this container is the model car container. So you can go into that, and then you see again the model data here. So this was a small one. Of course, you expect to start up quickly here as with the storage initializer as well. But now let's try the same thing with a larger one. So for that, I'm just prepared a large container which uses the Bloom 56 model. Let's look into the deployment, what I have here. So here you see that I'm referencing another image. So this contains a model which is around 3 GB large. And instead of running the PyTorch runtime itself, I'm just using a dummy image just for showing you the initialization. So you could use, of course, here the PyTorch runtime as well. But yeah, for demo's sake, I'm just using that one. And let's apply this here. Yeah, OCI. And actually I have to say I have run this demo already once before, and now let's look at the pod. How the good luck, we have still our old one, but actually you see that the Bloom already is running. So it takes 2 seconds to start this predictor pod here, which is really super quick compared to the traditional way when it will take around 5 minutes to download the 3 GB again during the initialization. Okay. Having that said that, let's jump now into the pod again. So in this case, we have this one. But now I just want to jump into the other one, in the model car container, not in the runtime container. And jump in here. Now we can also try PS. So in the runtime container, there was no PS installed, so I couldn't show that here. But here you see that actually you have all the commands from all the containers directly in the same process namespace. So you have this one, which is coming from the queue proxy from Knative service. You have this one. So I have running this on my M1 MacBook Pro Minikube, which means that I have here again a QEMU, which emulates for the AMD images, because my platform usually is ARM. And then I have this kind of dummy, which is a REST service, which I'm used usually for Knative service demos right now. Okay, and then we have the process which is coming from our model car, which is just a tail on dev null, which is an idle which a command which is just idling, so it does not take any CPU or memory actually. It's just do nothing. It just does nothing. And now let's look again into our volume. So we have mounted the MTD volume again under mount. We look here again, and you see again that this model directory, and what you see actually is that this PRD really corresponds to the PRD of our model car command. So this is the important thing, and this link has been created during the start of the model car itself. So this is part of the arguments in the pod and the container declaration for the pod itself. Now let's jump into the models directory here, and here you see something which I've just downloaded from somewhere, to be honest, because I'm really not a specialist in AI or ML, but actually, yeah. So this is a model, but what you can see here now is the size of this directory, and it's really about 3 gigabytes, which is really quite nice, I guess, because now you can, for example, you could set min scale for the inference service also back to 0 and scale up really in seconds like you would do with any other service, because the only thing that you need to do is to create the link. The image is already on the node. Other benefits of this approach is, of course, that you can pre-warm nodes with the image itself, so you can download the images ahead before you, for example, make an update, canary update or whatever for your inference service, and if you want to update to a new model. And theoretically, you could also benefit from other improvements or optimizations for downloading container images like star gset, which allows you to lazy load images. But for that, of course, your model needs to have also kind of a layered approach or must be split up in multiple files. Okay, so this kind of concludes my demo. I hope you get some insights how it works in theory. There are still some edges which needs to be ironed out. Please follow up the pull request. Leave out your comments. I'm really curious about your opinion, whether this would be useful for you or not. Thanks a lot.